morning. Good morning to everyone. Okay, good morning. Fast. Okay. So we were talking about right? So basic concepts of chemistry. So can anyone tell me which that is the word, which are those words which we have discussed? That concept word. Hmm? Okay, with my name, one student is that Raghavendra. Okay. Hmm? Can you tell me that word? So, in the last class, we have discussed about, yes, significant figures. Yes, one of the things which we have discussed is significant figures. So, have you practiced? Hmm? Have you practiced this one? Yes, all of you are right. We have discussed about the significant figures. Yes, which is an important concept with respect to your exam point of view. Fine. So now all of you have practiced. Okay, fine. So in that case, yes, scientific notation. I will come to that one. We have discussed even that one also. So now when I am talking about significant figures, can some of you tell me what is the number of significant figures in this particular number? So what are the significant figures in this? 0.097. Can any one of you? Okay. So all of you are telling 2. Very good. So that is 9 and 7. So it will be 2 significant figures. Now can any one of you tell me what is that number of significant figures in this? Okay, first one is fine. So I am talking about second one. What are the significant figures in this? Okay, very good. Yes, they are 9700. Fine. So what will be the number of significant figures in 2 into 10 to the power of 2? What is the number of significant figures in 2 into 10 to the power of 2? From where this 2 into 10 to the power of 2 came? Okay, someone has written 1. Absolutely correct. This will not be considered as a significant figure, so only 2 is the one which is the significant figure, therefore it should be 1, not 2. Okay, it should be 1. Only 2 will be considered as significant figures. So this is not considered as a significant figure. So it is a scientific notation. So instead of that, we can write it as 200. And all of us will know in this, only this is the one which is a significant figure, 2. So that 200 we have written in the scientific notation. So that is 2 into 10 to the power of 2, where 10 to the power of 2 will not be considered as a significant figure. It is just a scientific notation for the 200. 2 into 10 to the power of 2. All of you have understood? Fine. So if I have, or if someone tells you, I have 2 cricket ball with me, or I have 4 cricket ball with me, or whatever number. For example, we'll go with, I have 2 cricket ball with me. So what it means? That means he is specifying that he is having 2 cricket balls. So in that case, if I want to represent that one, I can represent it as 2.00, right? So I am specifying because he is telling I have 2 cricket balls. He is very much sure. So he is specifying that one. So I can write it as 2.00, or I can mention it as 2.0000, right? Or I can mention it as 2.000000. So like that the numbers can goes on, right? So that's what I was telling. So when I am specifying something, I have 2 cricket ball. That means it indicates that I can have the infinite significant figures. I can have the infinite significant figures because I can represent that one as 2.00, or I can represent that one as 2.0, whatever it is. So therefore we can tell that it is having infinite significant figures, right? So but I am specifying. Now when I am talking about this one, here it is not infinite. Here it is how many significant figures? 2. Here it is 3. Here it is 5. So like that we can specify when a value is given. But when a statement is given, we can tell that it will be having infinite significant figures. Fine. So that's what we have discussed in the previous class. Okay. So that's where scientific notation, it is also very important, which will come across in your calculations. Fine. Now when I am talking about next one with respect to the calculation, see for example I have 2 into 10 to the power of 2 divided by 2 into, simple numbers only I am taking, 10 to the power of 4. What is the answer for this? What should be the answer for this? Once again, a scientific notation, right? So where it should become 200, where it should be having 1, 2, 3, 4. So same thing I have represented in this manner. Same thing I have represented in this manner. That's where we have the scientific notation. So 2 zeros, 4 zeros. That's where I have the scientific notation. So Suhas only, right? Sneha, she has written 1 by 10, right? So in that case, anyway, this will get cancelled. So we can make it as 2 by 2 into 10 to the power of 2 minus 4. 10 to the power of 2 minus 4. When I take this one on the upper side, it will become minus. So therefore, 2 minus 4, that is nothing but, it will get cancelled. 1 into 10 to the power of minus 2. 1 into 10 to the power of minus 2. Right? So that's where Nanjunda Swami and Pratik, you people are correct. So that's where I have the 1 into 10 to the power of minus 2. That is nothing but 1 divided by 100. Right? So what is 10 to the power of 2? That is nothing but 100. But since there is a minus sign, that indicates that it should go to the denominator. It should go to the denominator if I want to write it in the 100. So 1 divided by 100. Right? So which can be represented as 0 point, because it should be in decimals, because 1 is a small number and 100 is a large number. So it should be in decimals, 0 point, right? So if I make it as 1, then it will become 1 divided by 10. If I make it as 0.1, it would have become 1 divided by 10. But here it is 1 divided by 100. So therefore, it should go to the position here, 0.01. You should take the position 0.01. Please remember, point something, that means divided by 10. 0.0 something, that means divided by 100. 0.00 something, then it is divided by 1000. Like that, placing will happen. All of you will agree? So that's where we have 1 by 10 is equal to 0.1. 1 by 100 is equal to 0.01. 1 by 1000 is equal to 0.001. So that's where we will be having the positions. So to avoid the mistakes, now see, to avoid these mistakes, we'll go with scientific notation. We will mention this one as 10 to the power of minus 1. A scientific representation, notation. So we can represent this one as 1 into 10 to the power of minus 1. Same way, 1 into 10 to the power of minus 2. That's where scientific notation will have the importance. So 1 into 10 to the power of minus 3. So that's where we have the advantage of scientific notation. Fine? All of you have understood? So these type of things you should know. You will come across these type of calculations. Okay? So in your exam they may not ask, give the answer for this particular value. No one will ask. But while solving the problem in the next chapters, so that's where you will come across all these things. Okay? So any doubts in this? Any doubt? So same way, I have, once again I will take simple numbers only. 2 into 10 to the power of 2 multiplied by, so I will have to use the bracket, multiplied by 2 into 10 to the power of 4. So what should be the answer? What should be the answer? It is nothing but 200 multiplied by 1, 2, 3, 4. So same thing I have written in the scientific notation. That's where I am talking about importance. Why we have to give importance for scientific notation? So much tedious. 0, 0, then 0, 0, 0, 0 I have to write. There is a chance of errors. Right? So to avoid that, I have written the same values in this form, in the scientific notation. So what will be the answer? I have to do 2 into 2. Then I have to go with 10 to the power of 2 plus 4. 10 to the power of 2 plus 4. Don't multiply 10 into 10. No. So 10 to the power of 2. Someone has given the answer. Very good. So that means 4 into 10 to the power of 6. So all these things you should remember. Fine. So when they are division part, then it will become minus. But when they are in multiplication, then it will become addition. All of you have understood? So that's where these type of things you should know. Now you can see, instead of writing 4 into 1, 2, 3, 4, 5, 6, right? So that means 4, 1, 2, 3, 4, 5, 6, right? So it's very difficult. There is a chance that I can make a mistake by not writing 1, 0. So to avoid these mistakes, we can simply write it with scientific notation. So 4 into 10 to the power of 6 is nothing but this value only. Okay? To be more specific, this value only. 4 into 10 to the power of 6. All of you have understood? Fine. So that shows the importance of the scientific notation, and that's how scientific notation, whenever it is there, it has to be solved. Okay, so these type of things you will come across whenever you are solving some of the problems. Any doubt in this? Okay, so shall I move to the next one then? Fine. Now, before going to different laws, we have different laws and all. So, before going to that, I want you to understand some of the concept like atomic mass. Okay, so atomic mass, then molecular mass. Now, please remember, some people they will call it as atomic weight, molecular weight, that is fine. Okay, meaning might be different, mass and weight, they are going to have different meanings, but still it has been accepted for convenient purpose. Okay, atomic mass, molecular mass, so formula mass. These are some of the things we should understand before going to that particular laws, which are very important. Okay, now all of us we know that atomic mass, that is nothing but related to the mass number of an element. That is nothing but mass number of the element, that is number of proton plus number of neutron. Anyway, these things you are going to discuss in your atomic structure topic, but for time being, for all the atom, they have their own mass, right? Like Raghavendra sir is having his own mass, which will be variable due to the COVID. Now mass has increased. Once the college will reopen, it may decrease. So there is a variation. But when it comes to atom, it cannot be variable. It will be a constant. Okay? Okay, carbon, in March month, it will be having one mass. After rainy season, it will have different mass. Not like that. That is applicable only for the living organisms. Right? So, but here, when it comes to atomic mass, it will be a constant for an element. It will be constant for an element. So, if I take a simple element, that is hydrogen atom, atomic mass of hydrogen atom can be represented as 1 atomic mass unit. Round off, I am making it as round off, 1 atomic mass unit. Or I can mention it as 1 unified mass. This is nothing but, try to understand this one, atomic mass unit, or this is unified mass, or I can tell it can be 1 gram. It can be 1 gram. Meanings are different. When it comes to these two, they are having same meaning. But when it comes to 1 gram, now the meaning will change. Now the meaning will change. Same logic is applicable. I have a molecule, molecular mass I want to identify. And how to find the molecular mass? See, for example, I can take the help of glucose, C6H12O6. To find the molecular mass, you should know which are those elements which are present, and you should know in what ratio they are present. So that's where to calculate these two, we should know molecular formula. We should know molecular formula of the compound. Otherwise, you cannot. So we should know molecular formula of that particular compound. Then only you can calculate these two. Fine. So that's where I have the molecular formula of glucose is C6H12O6. Okay, what I will do is, any doubt in this? Atomic mass of hydrogen can be expressed as 1 atomic mass unit, 1 unified mass or 1 gram. That 1 gram, it has a different meaning. I will come to that. But all of you have understood? Any doubt? Okay. So that is related to atomic mass. Now we will see how to calculate the molecular mass of a given molecule or compound. I have taken the example of glucose. I have taken the example of glucose. Calculation of molecular formula for glucose. Okay. Now, first we should know formula. Okay. Calculation of molecular mass for glucose. So it should be C6H12O6. Fine. Now in that case, how to find molecular mass of a glucose? So molecular mass of glucose is nothing but, or any compound, molecular mass is equal to sum of the atomic masses of elements present in the compound or molecule. So that's where we have the molecular mass. Now can you tell me glucose, whether it is a compound or molecule? We will see whether you have remembering or not. Whether glucose is a compound or molecule. Okay. Sneha. Oh, very good. Manjunath, you are also right. But glucose can also be called as a molecule or a compound. So that's what I told. It can be both. It can be both a molecule or a compound, because molecule is a broad term, right? But it can be more specific. If you want to tell, we can call it as a compound. Otherwise, yes, all of you are right. It can be compound or molecule. Fine. So that's where sum of the atomic mass of element present in a given compound or molecule. Right? So in that case, how many carbons are there? 6 carbon. Each carbon will have the 12 atomic mass unit, or I will write that one, atomic mass unit or unified mass or gram. Okay. So you can mention any one of these 3. I have taken all the 3 to make you understand. So why 6 into 12? Because we know that one carbon atomic mass is 12 AMU or unified mass or gram. Okay. So that's where one carbon mass. If I am talking about one carbon, then I can omit the gram. Okay. So for time being, I will go with only one carbon. Considering one carbon, I will take out the gram. Then I can tell 12 atomic mass unit or 12 unified mass. So that's where I have the carbon. So if that is the case, for one carbon, it is 12 atomic mass unit or unified mass. How much for 6 carbon? This is how you should calculate, right? So given information I know, for one carbon, 12 atomic mass unit. How much will be for 6 carbon? So carbon will get cancelled. The answer will be in terms of atomic mass unit or unified mass. If you are not understanding, let me know why we are calculating 6 into 12. That is because of this formula. For 1 carbon, it is 12 atomic mass unit. How much for 6 carbon? I want to identify for 6 carbon. Okay? Plus, because it is sum. It is the sum of the masses of the elements present in a given compound. Now, how many hydrogens are there? 12. Each hydrogen will weigh 1 atomic mass unit or unified mass. 1 atomic mass unit or unified mass plus how many oxygens are there? How many oxygen? 6. So 6 into each oxygen atom will weigh 16 atomic mass unit or 16 nu. 16 atomic mass unit or 16 nu. That's where unified mass. So this is where we have the calculation. So can some of you tell me what should be the answer? What should be the answer? 6 into 12 plus 12 into 1 plus 6 into 16. Right? So that's where we have the 6 2s are 12, 72 plus 12 plus 6 6 are 36, 96. Right? So it will be 96. So we have to add it up. We have to add it up. So that means 96, 72 and 12. So 6 4 are 10. 6 2 plus 2 it is 10. So 180. So that means atomic mass of glucose or molecular mass of glucose is very good. 180 atomic mass unit or unified mass. So this is how we should calculate. This is how we should calculate. All of you have understood? Any doubts? Okay. So unified mass or atomic mass unit. So this is related to glucose. Now my students are so innocent because they are not asking, Allah sir, ಅವಾಗಿಂದ ಅಟಾಮಿಕ್ ಮಾಸ್ ಯೂನಿಟ್ ಯೂನಿಫೈಡ್ ಮಾಸ್ ಹೇಳ್ತಾ ಇದ್ದಾರಲ್ವಾ ಅಂದ್ರೆ ಏನು ಸರ್ ಅದನ್ನ ಹೇಳಿ ವಾಟ್ ಯು ಮೀನ್ ಬೈ ಅಟಾಮಿಕ್ ಮಾಸ್ ಯೂನಿಟ್ ವಾಟ್ ಯು ಮೀನ್ ಬೈ ಯೂನಿಫೈಡ್ ಮಾಸ್ ಅದನ್ನ ಹೇಳೋದು ಬಿಟ್ಟು ಎಲ್ಲ ಹೇಳ್ತಾ ಇದ್ರಲ್ಲ ಸರ್ ರೈಟ್ that should be the question. Okay, fine. Anyway, I will tell now what is this atomic mass unit. Okay, so you can expect the definition for 1 mark. So what do you mean by atomic mass unit? Now which has been replaced by unified mass. Atomic mass unit. AMU. All are small letters. Okay. So that is nothing but a mass which is equal to the 1/12th of the 1 carbon 12 isotope. Answer. Okay. So atomic mass unit is nothing but it is a mass which is equals to mass of 1/12th of carbon 12 isotope. Okay, 1/12th of carbon 12 isotope, that is AMU. You might have studied in your high school. Fine. Say for example, carbon 12 isotope, I will consider it as a dosa or chapati, whichever you like. Okay, or any sweet. So I have a chapati. Now I have got 12 students. And Raghavendra sir is not going to discriminate among his students, no doubt. Right? So what he will do is, he will divide this dosa into 12 parts. If picture is wrong, don't tell me, it should be equal part. So if that is the case, don't think that Raghavendra sir is doing discrimination. Okay? So 1, 2, 3, 4, 5, 6, 7, 8. So once again we have to have now 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So I will make it another part. So now 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now definitely it looks like Ravindra sir is discriminating. Not like that. Imagine that all the parts are equal. Okay. Now in that any one part, either it can be 7th or 9th or 11th, whatever it is. Any one part if I take it out, whatever the mass will come out of this, that is nothing but 1/12 of carbon 12 isotope. All of you have understood? Any doubt in this? So that will be equal to 1/12. That meaning is same. Where 1, it has been divided into 12 equal parts. So in that one part is the mass. That is atomic mass unit. Okay. Anyway, no one will ask you the value and all. Definition you should remember. Okay. So that's why we have the atomic mass unit. So which can be somewhere around 1.66 into 10 to the power of minus 24 grams. Even some more digits are there. I have skipped. Okay, Kumar. Sir, why carbon atom? A good question. So very important point here is why carbon? Because one thing, due to their abundance in this nature, in biological system they are abundantly present, and in that carbon 12 because it is highly abundant isotope among all the carbon. Nearly 99% or 98 point something, nearly 99% of the carbon present in the nature will be of carbon 12 type. Okay, so therefore they have selected the carbon 12. Otherwise, earlier they used to take the oxygen as the standard. Now they are coming to the carbon 12. Okay, so that's where we have the atomic mass unit. Now in the sense recent agala, I think 1960s, so that's somewhere they have accepted carbon 12, we consider it as a standard, and to compare to that one, they used to calculate what is the mass of other atoms. Now anyway, we have so much sophisticated instruments are there. No need to worry. We have mass spectrometer which is able to calculate the mass of each atom. Okay, so that's where we have sophisticated instruments. But earlier it was not there. So by comparing with anyone, they used to tell what is the mass of the atom. Fine. So that's where we have the carbon 12 isotope. Okay, which is not a radioactive isotope. Okay, it is not a radioactive, it is a stable isotope. Fine. Any doubt? That's where we have the atomic mass unit. If I am mentioning hydrogen as one atomic mass unit, hydrogen as one atomic mass unit, right? So that's where we will be mentioning. That means when I am talking about carbon which is 12, when I am talking about carbon which is 12 atomic mass unit, that means hydrogen is 12 times lesser mass compared to carbon. So what it indicates? Hydrogen is 12 times less compared to carbon. Okay? So that's where we can tell in comparison. That's how we have got the atomic mass unit. That's where we have got the atomic mass unit. That is because what they found is one hydrogen will weigh 1.67 into 10 to the power of minus 24 gram, and 1/12 of carbon 12 is going to weigh 1.66 into 10 to the power of minus 24 gram. Okay. So now if you divide these two, if you want to identify what is the atomic mass unit for hydrogen, then you can tell that For 1.66 into 10 to the power of minus 24 gram, it is 1 atomic mass unit. How much for 1.67 into 10 to the power of minus 24 gram? That's how we can identify, we can calculate. No one will ask you to calculate. To make you understand, I am writing. Okay? So now, this will get cancelled, gram will get cancelled. So leftover is atomic mass unit. Now this will be somewhere around 1.008 something it will come. So by rounding it off, we can make it as 1 atomic mass unit or unified mass. Got my point? That is because one hydrogen atom is going to be approximately 1.67 into 10 to the power of minus 24 gram. Same way, 1 by 12th of carbon 12 isotope will have this much gram. That is nothing but 1 atomic mass unit. Therefore, for these many gram, it is 1 atomic mass unit. For these many gram, it will be how many atomic mass unit? So, we will get the answer as 1 atomic mass unit. Okay? So, this is called as rounding off. Instead of writing 1.008, we will make it round off as 1. Okay? So, any doubts in this? So, that's where we have the atomic mass unit. That's where we have the atomic mass unit. Any doubt? Can you imagine the importance of scientific notation? Here once again, 1.66 into 10 to the power of minus 24 gram we had written, right? If I go with non-scientific notation, oh my god, it will be 1.66 divided by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Can you imagine? You are going to write like this, right? So that's where a scientific notation is a simple way to write it off. Okay? Or otherwise also, if you take this one, it will become decimal point. If you take 0.1 I have taken, that means minus 25. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16, 17, 18, 19, 20, 22, 23, 24, 25. Now 166. Oh my god. It will be very tedious, right? It will be very tedious. That shows the importance of scientific notation. Okay? So that's where we have the importance of the scientific notation. All of you have understood? And another thing, what you can appreciate here is such a small value. 1 atomic mass unit is a very, very small value. You cannot imagine, right? So 0.00000 like that it will go, and then it will become 166 grams. A very small value. What is the mass of Raghavendra sir? No, we should not tell. So it is around 65 kg. If you take it as 65 kg, then measurable. Mass of Raghavendra sir or any one of us, it is measurable. But when I am talking about the atom, it is very difficult because very small mass. Right? So now, due to that, we have come up with another concept. That is mass of a substance. Mass of a substance. Where SI unit for this one will be mole. SI unit for this one will be mole. Okay? So now when I am talking about mole, what do you mean by mole? Mole is nothing but a number. amount of substance, right? Sorry, mass of substance are written. It should be amount of substance, right? So mole is nothing but a number, because we are talking about amount of substance. What is that amount of substance? So amount of substance, that is mole, is nothing but number of atoms or molecules, or it is applicable to anything, molecules or substance. Okay, number of atoms or molecules or substance which will be equals to number of substance which is equals to number of carbon 12 isotope present in 12 gram of carbon 12 isotope. Carbon 12 isotope. What my point? All of you have understood? So what is a mole? Mole is a substance. This number of substance. It's a number. It's not a mass. It's a number. So what is that number? That number is nothing but it is the number of atoms or molecules or any substance which is equals to the number of carbon 12 isotopes present in a 12 gram. Present in a 12 gram of carbon 12 isotope. So what I mean to tell you is, I have carbon 12. If you go to the market, okay, so if your mother is purchasing some vegetables, okay, for example, bhendi is there. So your mother will tell, give me 1 kg of that particular vegetable. He will weigh and he will give. So in that particular amount, there will be some numbers will be there, right? So number of bhendis will be different in different mass. Same way, if I take carbon 12 isotope, so if I weigh that one as 12 gram, because 1 carbon 12 will weigh very less. So I am weighing 12 gram. I am taking 12 gram of carbon 12 isotope. So that 12 gram should have some number. That number is nothing but number of, or 1 mole. That number is nothing but 1 mole. All of you have understood? Any doubt? You can have, you may be expecting the question, 1 mark question on this. All of you have understood? So therefore I will mention it this one as very important. Okay? So all of you have understood? Any doubt in this? So that's where we have the mole of a substance. That is nothing but amount of a substance. Way to express the amount of a substance. Fine? So which will be equals to the number of carbon 12 isotope present in its 12 gram. Present in its 12 gram. Right? And that number is nothing but 6.022 into 10 to the power of 23 number. 6.022 into 10 to the power of 23 numbers, which we will call it as Avogadro's number. Which we will call it as Avogadro's number. Symbol is Na. A should be subscript. Both should be capital. So that's where we have the Avogadro's number. Fine. So what is the mole of a substance? People will write Avogadro's number. That is wrong. That is not the definition. That is the value. Many students have seen. In the exam they will ask 1 mark question. Define a mole of a substance. They will write, students, they will write very simple answer. 6.022 into 10 to the power of 23 number. Done. But that is not the definition. That is the value of 1 mole. Their question is not value. They have asked, define the mole. Then you should tell that it is the number of atoms or molecules or substance which will be equals to the number of carbon 12 isotope present in its 12 gram. In its 12 gram or 12 gram of carbon 12 isotope. All of you have understood? So that's where we have the Avogadro's number. Any doubts? It's very important. Okay? So any doubt in this? If you are not understanding, let me know, please. There is a huge difference between atomic mass unit or unified mass and mole. There is a huge difference. They are not comparable. Okay? So, any doubts? That means, if I am coming to another word that is called as molar mass or atomic mass in grams. Atomic mass in grams. Okay? So molar mass, molecular mass in grams. I will mention it as molecular mass. Molecular mass in grams is nothing but molar mass. Molar mass. So molecular mass in grams means you know how to calculate the molecular weight of a substance. All of you know how to calculate the molecular weight of a substance. Now same way you should calculate, but only thing here is, for example, if I go with the glucose C6H12O6, what I will do is I will mention it as 6 into 12 gram plus 12 into 1 gram plus 6 into 16 gram. Everywhere I am using gram now. No atomic mass unit. I am using the gram. So 6 into 12 gram, 12 into 1 gram, 6 into 16 gram. Anyway, final answer will be 180 only. But unit will be different. Unit will be mentioned as grams. That's where the huge difference between 180 nu or atomic mass unit for glucose and 180 gram for molecular mass of the glucose. 180 nu or atomic mass unit of glucose, there is a huge difference between this one and this one. But both are related to glucose only. But there is a huge difference. There is a huge difference. Right? All of you have understood? So whenever I am mentioning, listen to me carefully. Whenever I am mentioning glucose as 180 nu, 180 atomic mass unit or 180 unified mass, that means I am talking about, observe it carefully, I am talking about one molecule of glucose. I am talking about one molecule of glucose. So this is related to one molecule of glucose. But when I am telling 180 gram, it is nothing but 1 mole of glucose. That's where there is a huge difference between these two. 180 nu is nothing but, or 180 atomic mass unit is nothing but 1 molecule of glucose. And 1 mole of glucose is nothing but 180 gram. All of you have understood? Any doubts? Any doubts in this case? That's where we have the difference between 180 unified mass or atomic mass unit and 180 gram. So 180 gram is nothing but related to mass of 1 mole of glucose. And 180 unified mass or atomic mass unit is nothing but mass of 1 molecule of glucose. Okay? So very good. So in that case, please remember, if you have any doubt, no need to hesitate. I am ready to explain any number of times. No need to worry. Okay, if you have any doubts, let me know. So that's where we have the concept like atomic mass unit or unified mass and mass of the or molar mass, that is mole. Okay, so what we have discussed here is that is related to atomic mass unit or unified mass. Then we have discussed about mole. Then we have discussed about molar mass, right? So that's where we have the difference. Fine, all of you have understood. So now in that case, what do you mean by molar mass of a substance? Any one of you? I have explained already. What do you mean by molar mass? Just now I have explained. What do you mean by molar mass of a substance? What is the molar mass? Define the molar mass. Now, one atomic mass unit or unified mass is nothing but it is the mass equals to 1 by 12th of the carbon 12 isotope. One is done. What is mole? It's a number. It's not a mass. It's a number which is equal to the number of carbon 12 isotope present in its 12 gram. Right? So that's where we have the mole. It's a number. Now I am talking about molar mass. Atomic mass unit, mass. Molar mass. Here also mass is there. So what should be the molar mass? Now, molar mass is nothing but it is the mass of 1 mole of a substance. It is the mass of 1 mole of a substance. Got my point? It is the mass of 1 mole of a substance. That is nothing but molar mass. That is nothing but molar mass. Okay? The ratio of mass of one molecule of the compound. Why that a ratio? Okay? So to be more simple, this can be the answer. It is the mass of 1 mole of a substance. That is enough. Okay? Anything I can take. If I take 1 mole of Raghavendra sir, oh, it's unimaginable. If I take 1 mole of Raghavendra sir, that means 1 Raghavendra sir will weigh 65 kg. In that case, 1 mole means 6.022 into 10 to the power of 23 number of Raghavendra sir. That means Raghavendra sir. This will cancel. Whatever answer comes, it will be in kg. Then it will be, I don't know. We cannot imagine. It will be, I think, more than the mass of the universe, I think so. Right? So that's why it will be a huge number. And that number is molar mass of Raghavendra sir. That number is nothing but molar mass of Raghavendra sir. All of you have understood? That's why, please remember, whenever they are telling carbon 12 gram, atomic mass or mass of the carbon atom is 12 gram. That means they are talking about 1 mole of carbon, not 1 carbon. Please remember, that's where you should appreciate this. Otherwise, our body is made up of n, infinity, we don't know how much, n number of carbon. Our body is having n number of carbon. If each carbon will start weighing 12 gram, the total mass of Raghavendra sir would have been a mass of the universe or more than that. We don't know. Right? Unimaginable. So that means if I take 6.022, I have written it as 6022 into 10 to the power of 20. Now it will become into the 10 to the power of 20. So therefore 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. That means so many number of carbon, 12 isotope if I take. So many number of carbon 12 isotope if I take, it will just weigh 12 gram. Very less mass for so many numbers. If I take so many numbers of carbon 12 isotope, it will just weigh 12 gram. That's where we should appreciate the molar mass. Okay? So it's a very less value compared to this number. So that's where we are saved. It's not one carbon which is weighing 12 gram. It is the 1 mole of carbon which is weighing 12 gram. All of you have understood? Please remember, they are all very important concepts. You have to remember. Okay? So therefore I told this chapter is very important. If you learn this chapter and few other chapters, then you will start appreciating chemistry. Otherwise it will become a mystery. Right? Mystery means what? Where we don't know what is happening. Right? So one should not be doing like that. I want my students should be understanding the concept properly. Fine. Any doubt? And you can go home today. Once again you can go through everything. In your NCERT book also it is given nicely. Go through that. Or your check sheet you can follow that one. Any doubts? If you are not understanding, you can ask that one. Fine. But any doubt at present? Always my students will not have any doubt. Any doubt? Okay, sir, you did not send the check sheets. Okay, madam might have sent, na? Madam will be sending. Okay. Anyway, I will just ask the madam, or you can only ask the madam also whether it has been sent, because I don't have idea. Means no sir in the sense check sheet has not been sent or it has been sent. Okay, fine, don't worry, it will be given. Don't worry. But any doubts? Oh, no sir in the sense no doubts, sir. Okay, fine. But check sheet will be given, don't worry. Fine. In that case, thank you. Take care. Bye. Okay, fine. Thank you.